It starts with a flash that no one on Earth can see. Far above the atmosphere, nearly 600 kilometers above the Pacific Ocean, a small object moving at 8 kilometers per second collides with something else. There is no explosion, no fireball, no sound, just physics. Metal meets metal at orbital velocity. And suddenly, a satellite the size of a refrigerator becomes a cloud of thousands of fragments. Each fragment now moves through space like a bullet, at the same speed, at the same altitude. In the next 30 minutes, those fragments will cross the orbital paths of dozens of other satellites. And that is when the real damage begins. Because satellites don't explode in dramatic bursts, they die quietly, one by one, until suddenly, the sky above Earth is no longer safe for machines. And modern civilization begins losing the invisible systems it never realized it depended on. On screen, hundreds of objects, then on screen, hundreds of objects, then thousands. The computer automatically calculates trajectories, and the number appears. Impact probability, escalating. The system immediately flags the event as a potential orbital debris cascade. But no one wants to say the words yet, because if they are right, this isn't just one satellite failure. It is the beginning of something scientists have warned about for decades: the Kessler Syndrome, a chain reaction of collisions that turns low Earth orbit into a shooting gallery. Within minutes, automated alerts reach satellite operators around the world. Commercial imaging companies, navigation networks, military communication systems, weather monitoring satellites, all receive the same message. Potential debris field detected. Collision probability increasing. Satellite operators attempt evasive maneuvers. But satellites cannot dodge quickly. They move at predictable speeds along fixed orbits. Adjustments require fuel, and many satellites don't have much left. Within the next hour, 2 more satellites vanish from the tracking network. No explosion, no dramatic signal, just silence. Debris in orbit is invisible to the naked eye. Even the largest fragments are smaller than a smartphone. But at orbital speed, size doesn't matter. A paint chip moving at 8 kilometers per second carries the energy of a bullet. A bolt can destroy a solar panel. A shard can pierce critical electronics. And once debris spreads across orbital lanes, the probability of new collisions rises exponentially. The first debris cloud crosses paths with another satellite cluster. A weather monitoring satellite is hit, then a communication satellite. Each impact creates more fragments, and each fragment creates new threats. A chain reaction has begun. On the ground, life continues. People scroll through social media. Airplanes cross the sky. Ships navigate the oceans. No one sees what is happening above them, because the destruction is happening in silence, hundreds of kilometers overhead. But in control centers around the world, the mood changes. Operators stop talking. Engineers stare at trajectory models. The simulations are clear. If the cascade continues for several hours, hundreds of satellites could be lost. And satellites are not just space hardware. They are infrastructure, navigation, communication, weather prediction, military surveillance, banking synchronization. All of it lives above the atmosphere. The first noticeable disruptions appear in satellite internet networks. Connections drop intermittently. Users assume it's a routine outage, but engineers know something else. Several relay satellites have gone offline. Replacement routing begins immediately, but bandwidth decreases, latency increases, small inconveniences, for now. Meanwhile, another collision occurs. A commercial imaging satellite fragments into hundreds of new pieces. The debris cloud expands. Orbital traffic models update again. The number of threatened satellites climbs. Defense departments around the world receive classified alerts. Space situational awareness systems report abnormal debris activity. The immediate question is simple: was this an accident or an attack? Anti-satellite weapons have been tested before. China demonstrated one in 2007. Russia tested another decades later. Both created debris fields, but nothing on this scale. If this cascade is intentional, it represents a new type of warfare, not targeting cities, not targeting armies, targeting infrastructure in orbit, destroy the satellites, and the systems on Earth slowly lose coordination. GPS satellites remain intact, but several supporting systems are now threatened by debris trajectories. Some navigation augmentation satellites shut down preemptively. Precision positioning begins degrading slightly. Commercial shipping notices minor navigation errors. A few aircraft report increased reliance on backup systems. Still manageable, still controlled, but the trend is clear. Orbital debris continues spreading, and the number of safe operational lanes decreases. Astronomers are the first civilians to see it. Telescopes tracking satellites detect unusual streaks of light. Debris, clouds reflecting sunlight. Orbiting fragments scatter across the sky like invisible rain. At certain angles, they briefly flash against the darkness. Within hours, social media begins filling with strange reports. Something moving across the sky? Satellite storms. People assume meteor showers, but meteor showers burn up in the atmosphere. These fragments stay in orbit, circling Earth every 90 minutes. Several military communication satellites initiate emergency shutdowns. Operators cannot risk uncontrolled collisions. Backup networks activate, but coverage gaps appear. Certain remote regions lose satellite connectivity. Ships crossing the Pacific begin experiencing intermittent communication delays. Deep-sea oil platforms lose real-time data feeds. Nothing catastrophic, yet. But the system is thinning, and satellites cannot be replaced quickly. Launching a new one takes months, sometimes years. Another major collision occurs. A retired satellite, long considered harmless, is struck by debris. The impact shatters it completely. Thousands of new fragments spread across two orbital planes. Simulation models update again. This time, the numbers are worse. The debris density in parts of low Earth orbit has doubled, which means the probability of new collisions doubles too. The cascade feeds itself. Every collision makes the next one more likely. Commercial aviation still flies normally, but satellite-based tracking becomes less reliable in certain regions. Air traffic controllers switch more frequently to radar. Oceanic routes, which depend heavily on satellite tracking, slow operations slightly. Pilots receive new guidance. Expect intermittent navigation and degradation. Prepare manual verification. Air travel continues. But redundancy is now carrying the load. By the end of the first 24 hours, the damage becomes measurable. Dozens of satellites have been lost. Hundreds are maneuvering to avoid debris. Thousands of fragments now orbit Earth. Most people on the ground still don't understand what has happened. Because civilization doesn't collapse when satellites disappear. It degrades. Quietly, navigation becomes less precise. Communication becomes less stable. Weather forecasting becomes less accurate. Financial networks lose synchronization signals. Small errors begin accumulating. The sky above Earth is no longer orderly. It is crowded. And the chain reaction has not stopped, because the debris will continue orbiting for years, maybe decades. Every 90 minutes, fragments sweep across orbital lanes again, waiting for the next collision, waiting for the next satellite to die. That night, as people look up at the stars, nothing appears different. The sky still looks calm, peaceful. But above that calm darkness, something fundamental has changed. The machines that orbit Earth, the silent infrastructure of modern civilization, are now navigating a minefield. And once space becomes dangerous, it stays dangerous for a very long time, because gravity brings objects down eventually. But in orbit, time moves differently, and debris never sleeps.